What is up, YouTube? Welcome to episode 26 of the Chaos Daily. Let's get straight into it. So, I'm working on the Chaos Albatross, right? And last night I'm working on the tail section, getting all the internal structure of the tail section, the hinge assembly for the ruddervons. Are they ruddervons? When they're on a V-tail, are they ruddervon? Because if it's a delta or a wing and they're aileron elevators, they're elevons. But if they're rudder elevators, they're ruddervons, right? Right? Okay, anyways. So I'm working on the rudderons. Tail is done. I got that done last night. But yeah, I was sort of just mucking around and forgot to hit record or set up my recording, so I've got no recording of that. But then today, I did all of the fuselage. It's almost done. There's a few little bits and pieces, tweaks and stuff to do in the fuselage. Working out servo mounts, the guide channels for the control wires that run through the tail to the ruddervons. Yeah, so I've got channels in the tail assembly for those wires to come through the carbon fiber tube and then split out through the tail fuselage to the control hinges. So that all worked out really nice. Whether it works out in practice, I don't know. I've used that sort of method on a couple of my other DLGs and gliders before, where you just have a stiff rod that has a bit of flex to it and you push it in and out and it sort of goes around and bends and stuff. It works fine. So yeah, just working out where to put the servos inside the fuselage, because they still have to go around the battery. See, I've never had to deal with the battery in the way before, so we'll work it out. Anyways, so yeah, working on the fuselage today. I've got heaps recorded, so we're going to jump straight into the time-lapse, and then at the end of it, we'll jump into Inventor, and I'll show you what I've done. So, see you on the other side.
We have some form of control still, making our constant binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide what color to wear or which burger to eat. What does it matter, man? Autonomy is an illusion. Autonomy is an illusion. Autonomy is an illusion. Most people can't even decide what color to wear or which burger to eat. What does it matter, man? Autonomy is an illusion. Autonomy is an illusion.
to say I just calling to say I
So there you go. You guys drop a comment down below. Let me know if you guys don't like the time lapses, if that's a waste of time and you just want me to get straight onto the thing. It's very difficult for me at the moment, right? I'm doing the daily thing as a vlog, right? You don't have to watch the daily thing. Because I've put the Draco on hold, I don't have a weekly episode coming out anymore. I'm probably going to do a weekly episode going over the Long Easy and also this Albatross when it's done. I'll sort of do like a montage build thing that I'll release each week or whatever. I don't know. I'll figure it out. But yeah, because I put those projects on hold and I don't have weekly episodes coming out now, this is my only content going up and it's a daily thing, then I need content. My printer's not here, so I feel bad that it's always just the same thing for you guys. But yeah, this is just the way it is. Anyways, so let's jump into Inventor and see what I've got done. Is that cool or what, right? So let's have a look at the tail first, because I did that first even though you don't see it in the time lapse. So you can see just here, these are these two little holes that I mentioned. So when your carbon fiber tube goes into the socket, those wires, those thick, it's like a spring steel or something almost, or you can even, there are some thin carbon fiber rods that you can also use that do the same thing. It runs through the length of the tube and it comes from the fuselage where it's hooked up to the servos in the fuselage, and then it runs the length of this, and because it's stiff, it doesn't really have much room to bend out of the way when you push on it, so it just gets pushed down the guide tube, goes through here and then out these vanes, and then it bends back a little bit where you'll connect it up to the control horn. It's worked on some of my DLGs before, and like I was saying before, I'm not sure if the battery is going to get away inside the fuselage compartment of that from that working. If so, I have to move the servos behind the battery, which means I need to make another access hatch further back behind the wing for you to set up the servos and access the servos, which is not a huge deal, but I'd prefer not to. I'd like to keep this as simple as possible. So just adding more complexity like that, I think it's a bit outside of the scope of what I'm trying to achieve here. We've got the hinges, they work. Same methods I used for the Long Easy. You're using carbon fiber rod that runs through the middle that acts as your hinge. I know this isn't popular with a lot of people. They prefer to just use a tape hinge, actual hinges, but this should work fine. So there's a carbon fiber rod that runs through here, and there's another carbon fiber rod that runs through this section parallel to it that will connect these segments all together. Nice and simple. I can jump into wireframe for you if you want, and you can see how everything looks. Isn't that cool? Let's jump back over to the fuselage. Over at the fuselage, you can see I've got the access hatch. This gets printed in 2 parts. You got the motor mount that gets printed on this face here, I believe. Yes. Then there's this section that gets printed on this face. It has a key that it plugs into the nose section, so everything lines up, and that also adds rigidity going around the skin. You can see it just like that there. You can see how it goes around. Same with this section, and then again, same with this section. They all have keys. The only difference is with this one, it is 2 holes, and then there's a ring. And you can see this ring here. So this is like an alignment ring that attaches between those 2 segments. You can see there's this groove that runs around, and that groove is mirrored onto the other part in front of it. So that alignment rings, you glue all that together and that becomes one big solid piece. I'm still figuring out how I want to do the spars for the wings. One of the things I'm having some trouble with the wings is with the carbon fiber that I've got. So I'm going to be using carbon fiber tubes that I've got. These are ones you can buy on eBay. They're pretty cheap. I'm using these 750mm square tubes. They're 10mm by 10mm square. These are great. They're mega strong. Problem is how I'm attaching the end of it into the wing socket, into the wing root on the fuselage. I'm going to have to beef up either the plastic there in the wing root so that you can slot this in there and with the whole wing attached. But on top of that, I'm also going to need to put an additional through spar. Now the problem is the wings have a dihedral, so the way that this one slots in, if you have one that goes through both wings, it will not be on the same angle as this, which means this will have to be loose inside the wing so that you can slot the wing on first and then slot this in through, and then that creates a cross angle bind between these 2 spars, which makes it much stronger. So I think that's the way I'm going to go with it, but that means that this has to be loose and the wing's going to have to be, it's going to be printed in multiple segments, but for assembly, you're going to have the main section, which will have the aileron built into it and the servo housings, and that'll have a channel for your servo wires, and then the wing tip. And the wing tip, I'm going to secure using these 3mm rods. You slot that onto the end there, and then for securing it, tape works fine. Otherwise, nylon screws. I'll work with nylon screws. I'll design nylon screws to screw it all together. But that's tomorrow's issue. Well, maybe the day after. I'm still working in the fuselage. But yeah, those are some of the concerns I have for the wing roots. So that's for some of the concerns that I have for the wings and the wing setups at the moment. I'm still thinking about it. But for the tail is nice and easy. The tail uses these 4mm spars. These are those medical grade ones my mum brings home. These things are ridiculously strong. Like, it's a 4mm. I'm a strong guy. If you don't know, I'm a very strong guy. I can barely bend this. So there'll be 2 of these in each of the V tails. So one will be the carbon fiber hinge for the the rudder one, and the other will be the main spar that runs through. And they all go into the center, pretty close to each other. Plenty of plastic in there to support these, so you can pop these in and get it all nice and stiff, and it'll be great. On the motor mount side of things, I've made the motor mount integral to the nose section. I may or may not change this in case you guys have a crash and it busts the motor mount, but yeah. I don't see that as being a beneficial thing to do just for being able to replace the nose. If you have a crash that breaks the nose on this, there'll be other stuff that breaks along with it just because of how strong the plastic is and the limits of all the other material, the other structure in it. So if this breaks, then that means something else is broken. You probably have to reprint the whole plane, so it's not a big issue. I've designed it so that when this section prints, and it'll print on this face, remember, you will need some support structure to support this face for the motor mount, but that'll be about it for this one and for the tail. You may need some support structure to support this internal section for where the tube comes in on the other side. So those are the only 2 that will need support structure. Also so there's 3 that need support structure. The nose, the fuselage tail, and this core section of the tail here where this is. You'll need to support this surface in the inside here. So a little bit of support material, it's not a huge deal, but if I design it any other way, you have to assemble it in different ways, and I lose the strength of the structure doing it that way, and I don't want to lose that strength because I've designed this in a particular way to keep it as light as possible. If you want to know how light this is, let's have a look. If you're using just straight PLA for all of the tail section and all of the fuselage, including the hatch and all the attaching ring in here, so far only weighs, drum roll please, 176 grams. I think I'm getting better at this. That is a great number. That is an excellent number, especially for a glider. Chuck in another, let's go crazy. Chuck in another 200 grams for the wings. That is a 400 gram aircraft weight. And then I'm gonna put like a 500 gram battery in this thing so I can run these 4S motors. So I want this thing going vertical and doing all sorts of weird shit. But yeah, so I haven't looked at the weight of this the whole way through the design. And right here, just before I started recording this video, I was like, okay, let's have a see what I've done. Because I was expecting this number to be in the 300s, to be honest. And when I looked at that number, and I went, wow. That was a big surprise for me. I was super happy with that result. So yeah, let me know what you guys think. I've been feeling a little bit down this last couple of weeks, mostly because I've been watching my YouTube analytics and they've sort of been just going down a cliff. I think it's got something to do with this time of the year, or the fact that I'm not going to be uploading weekly episodes, but it hasn't even been a week since I said that, so that can't be it. But yeah, so I'm just banging my head against a wall trying to get the YouTube algorithm to suggest my channel to more people. I don't know if it's a combination of the name that I've chosen, Chaos. I don't know if it's on some sort of algorithm blacklist or something, or if it's just the way that I title my videos or my thumbnails, or I don't know what it is. I've tried a number of different things and it doesn't seem to be helping. Thankfully, I have really great support from both my patrons and the rest of you guys that do come and watch my videos regularly. That is the one thing I absolutely know for sure is how much you guys are behind me, is the fact that every single time I upload a video, without fail, I get the same number of views, which means that you guys aren't going anywhere, which I am so thankful for. So thank you very much. The best thing you can do is help spread the word of the channel. With my printer coming soon, this needs to get out there. Like, people need to know what I'm doing here. So yeah, a bit of help, Facebook channels or forum posts or whatever. So I don't know why when I just do it, it doesn't really help. But when, for instance, when Simon went and shared a whole bunch of videos on Facebook, there was just a huge increase in views on my channel, and that was so cool. And I'm so thankful to Simon and my other patrons. They are so awesome. I love them. And yeah, so let's finish the episode here. I'm so excited. Printer's coming. We're going to get this going. I'm going to take it to the field. It'll bring you guys along. I'm just going to chuck it straight up in the air and just go full motor, go. And it'll either go great or it'll just go boom. And I'll be like, cool, I've learned a thing. So yeah, hit that like button. Make sure you're subscribed and hit the notification bell if you haven't. Go check out my Patreon if you can. There's also a donate link down below if you just want to buy me a coffee. So I've been Chaos, and as always, expect the unexpected. And I will see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.